So we're going to talk about parser combinators in Swift. My name is TJ. I've used parser combinators. I'll show that towards the end if I have the time. I've implemented these in Swift. This is all based on a paper by Meyer and Hutton. And it's a great paper. It's written in Haskell, and I stole what I could. And so let's just get right into it. Because I'm assuming that most of you probably don't have a lot of background in Swift, which is an assumption on my part, I know. But I feel like this will go a little bit better if you feel like you've been eased in, even if you haven't. So here's some math. 1 plus 1, that you're familiar with that. We can start here at a place that you're familiar with. And I can say, okay, well, you want to tell the world usually what that is. If you were typing this in a playground, just 1 plus 1 might show you something, but if you were doing it in your code, nothing would happen, so let's print it. And then that outputs 2 as you would hopefully expect. That 1 is just inferred to be an integer. But if you look, we have integers, we have strings, we have doubles, we have floats, true, false, plenty of other types. But you can see there, the syntax that I'm using is sort of close, but sort of reversed. If we look at just a function, this function adds 1 to a given integer. On the left-hand side, you can see that parentheses, the tuple of input, an int, that says that we accept an int. And then that arrow means that we return an int from this function. Of course, the func in the beginning means that I'm declaring a function, and it's named add1. And that works as you would expect. Right? You can call it, and that looks sort of C-like. Right? I'm just going to add a little bit more so that later on, if I use this syntax, you are familiar with it. You can also label the things that you are accepting. So here I'm saying 2 just because that reads a little bit more like what you would say. Add 1, 2, or add 2, and I didn't change the bottom there, so I'm calling a different function. All right? So now you know Swift. All right? Okay, so now we're going to get to the parsers part. Really, I just didn't want to just throw you into reading some Swift, because the first thing that we read is a little bit more involved. Right? It has some more moving parts, but now you have seen that func. You have seen the func. So parser, right, accepts input, which is a list of characters, and right now we're going to stick with a list of characters, or an array of characters, even though that's not what you would accept in string Swift typically, because that's not idiomatic, but it's conceptually what a string is, right? An array of characters, right? It's a sequence, an ordered sequence of characters, right? So we accept input, and then we return something. That's parsing, right? That's it. We're done, right? Like that's exactly what you're going to want to do, right? Well, all right. Well, let's complicate this a little bit, because chances are I'm going to accept this array of characters, and I'm going to give you something, but I might not finish eating the whole string, right? I might find the first part, the thing that you want, and say, but the rest of the string is not what I look for. Okay? So I'm going to return a tuple, right? And I'm going to assume that most of you are familiar with tuples. So, we return output, and we return an array of characters, which is just the rest. Okay? I'm speaking quickly, but if you have a question, or if I skip, if I lied some important thing that stops you from understanding, please raise your hand, and I will answer your question, or pretend to at least. So we have a choice to make here, actually, because what do you do when you fail? Right? When you fail to parse something, do I return sort of an array of these results that I just talked to you about, which is what the paper does, is the reason that I bring it up. Or do you return a maybe, right, or an optional? And I chose optional, but I want to acknowledge that they're both decisions that you can make. For efficiency's sake, optional was actually the better choice, and usually what you want is the first result, right? But an argument can be made for returning a list of like all of the possible things that, as we went. But again, I'm not going to spend too much time on that just because it's not necessary. I chose the second one. Does everyone understand what I'm saying when I present these two options here? Because this is a pretty important if you go read the paper, because they don't do what I do from now on, right? Like they chose the other path, all right? All right, so, awesome. Well, I said output in the beginning, right? And you all trusted me, and no one raised a hand and was like, well, you didn't show output as one of the types. Well, output is a generic, we parameterize over that type. We abstract over that type. We say, I'm going to parse for something. I don't know what right now. You can tell me that later, so that's just a placeholder. Output is a placeholder, and the syntax for that is the angle bracket after parser, saying that that's what we're generic over. And you can see that you're reading pretty good Swift now, right? Like, we started 5 to 10 minutes ago, and now you're looking at that like, yeah, old hat. Old hat. I remember when that was confusing. Right? So now we have structs, right? And now that you're familiar with that angle bracket syntax, right, you can tell that this struct, this type that we're making, which is a product type, if you're like, I don't know what a struct is, right? We're going to simplify this so that later on when we're talking about it, we don't have to write out that whole complicated thing for output for our parsers. This is the result of an old implementation detail in terms of Swift, right? Let's go back one slide. The paper continues to use functions because, well, functional programming. Right? You can use functions very much as types and parameterize over them and be generic over them and manipulate them in a way that is a little bit more fundamental than in Swift. Making something generic in Swift is easier for structs and classes and things like that than it is for functions. Some of that changed since I wrote the library that actually inspired all of this. But it's actually just nicer to continue and wrap this function in a structure, right? Wrap it in a struct, and then you can add methods to that struct that work with the particular type that you're wrapping. So that's what we're doing in this slide. I'm saying, all right, just a parser type in general can output anything. And when I refer to an instance of a parser, I'm referring to that function that is the parser. Now we're going to get a little bit more complicated. Y'all are reading some complicated Swift. Yeah. Right? So we have that instance up at the top, and then I'm just going to store one. Right? When I make an actual instance of a parser struct, all I'm doing is accepting an instance of a function, and I'm storing it. I'm keeping it for later. So it really is just a thin wrapper over that function. This is important. So if anyone's like, I don't know what you mean, raise a hand. I will try to make some sense. The initializer accepts an instance.
Is there a reason the type alias is inside the struct rather than outside? Is it even possible?
Yes. So you can put the type. So the question was, is there a reason that the type alias is inside the struct as opposed to outside the struct? Right? Is it even possible to put the type alias outside the struct? And it means two different things. So if I put the type alias outside the struct, actually it wouldn't compile because output wouldn't be a valid thing unless I had it somewhere else, right? Putting it inside the struct means that this type has an associated type alias. I shouldn't use associated. This type, parser, when you make an actual type from it, like giving it a type for output, so parser int, right? There is an associated, there's that word again. There is a type alias, right? There's another type that you can talk about now that I know what type it is, right? Like now that I know what type parser is. Yeah.
So this is basically Swift's version of new type?
Yes, a weaker version of new type. Right? Like this is, we were actually trying to get new type in Swift, but yes.
So Swift is the lowercase for instances and uppercase for classes. Is that part of the language, or is that just your convention?
It is idiomatic, but it is not enforced. which is sad making for me. So then I store this instance that you handed me, and I actually just keep it, right? So again, this is all just a thin wrapper. I'm really trying to emphasize this because as I move on, that's an important point, right? As you read the paper, there is no wrapper around the function. You just you compose the functions as, Haskell's beauty allows you to do. Now that we have that, right, how do we actually use our parser? We just have apply. And apply, if you look at that, if you sort of squint just a little bit and apply, what does apply's type resemble? Parser. Louder with confidence.
Parser.
Parser. Right? It resembles parser because all I'm doing is taking the instance that I have and using it. Right? So again, thin wrapper. All right. Okay. So now you understand the small part, right? Like the foundation of this. So let's get on to some building blocks. So we have three basic parsers that we're going to build everything else from. Right? And this is actually fairly important. How many of you are familiar with parser combinators just from some other language? Oh, well that simplifies things a little bit. There are some people who didn't raise their hands, so I'm still going to explain this, right? So let's start with result. Result is like, yay, we found it, right? So result is like, yay, we found it. I'm not going to consume any of the string, right? What I'm going to do is I'm going to say, you tell me what to return when you call me, and then whenever you call me, I'll give that back to you, and the string that is handed to me. This is useful for actually delivering a value at the end of parsing. Right? It's sort of tricky to think about it all in isolation, so don't think about it too hard in isolation. Just think about the fact that when you make a parser with result, you're making a parser that will just give you whatever you have handed it and the string. Okay? No consumption of it, so the remainder equals the input. Okay? This is just a little simplification of that same syntax. So if you look here, like I'm really trying to get you familiar with Swift. On the right here, where we have instance, colon, curly bracket, input, in, right? Like there's a little bit that we can cut out because before that we have the open paren. This is just the trailing closure syntax in Swift. So if you see code like this, they're equivalent, right? So it's hard to see what disappeared. See that instance just after return parser? The word instance? See how that disappeared along with the open paren? That's it, right? I'm going to use that syntax going forward. So just in your mind, if you're like, what? Just replace that thing. 0 just says we failed, right? In the same way that result doesn't care about the input, 0 doesn't care about the input. 0 says, failure. I don't even really care what you handed me. It didn't work. It's sort of like a teenager, a sullen teenager, just nothing. Doesn't matter what you give me. Nothing. You get nothing back. And so we can ignore our input, right? Because we're using maybe, right? We can ignore our input. Now, at some point, you're probably going to want to do something more complicated than this for failure because you're going to want to report errors and why you failed and stuff like that. But at its simplest, you just fail. You just say nothing. If you went with the array or list of lists, it would be an empty list. All right, so then we have item. And this is where things start to get interesting, and this is where we add more code as well. So item will just take the first thing in the array of characters or the string that you've handed us, right? And it will return that tupled with the rest of the string. Right? So the first two results, didn't care about the string, 0 didn't care about the string. This one does. This is just going to say, all right, well, I'll take, if you gave me happy, right, I'm going to take the H, and then I'm going to return happy as well. Questions about those three parsers? All right. And mind you, those aren't instances of parsers. You actually have to give them a value or give them a string, you know, like that sort of thing to actually make them real. All right, so let our parsers combine. One person is old enough. Right? Now we're going to use bind. And I'm not even yet, just bind. What we're going to do is we're going to bind two parsers. So we have those three basic parsers, and we need to actually combine them to do anything useful. The bind method, I'm just going to talk about it at a high level quickly because we're running low on time now. What it does is it says, all right, well, if the first parser that you have handed me succeeds in parsing the string, I will pass its output to the second one, and then, you know, whether or not it, you know, succeeds or fails, just that's what I return. Okay, I'm going to give you a new parser that will do that. I think a lot of people in the room are probably familiar with bind in general as an idea. If you're not, please talk to me afterwards. But trust me when I say that if you give me a parser of A and a parser of B, right? Like I'm going to run this parser and say, okay, well if this succeeds, then I'll hand A to there, and okay. All right, so now you have this new output type, and that all works, right? But let's actually skip ahead just a little bit, because we now know how to like make a new bound parser that combined these things. Like we can say, well, get the first letter, and if the first letter is what we wanted it to be, then you can return a success, and okay, well, let's see what that actually looks like. To do that, we need satisfy, right? And this is just a little function, right? Given some function that checks one of those characters, which we can pull apart using item, right? Item pulls apart our string character by character. If we can examine individual characters and say, well, is this what we want? Is this not what we want? Combine that with a parser, and we can make a new parser that will recognize specific input. What does that look like? Well, char. And this $0 is just saying the first argument to the closure that you hand us, right? And that closure that you hand us goes from char to bool, remember? Okay. All right, take another break real quick. I know we're going real fast. You're learning Swift at a breakneck speed. Right? Using satisfy, we can actually make pretty nice parsers here. We can make something that recognizes lowercase, uppercase, digits, and all that. There's the syntax where it is within range. I was pleased when I figured that out. I was like, oh, that's actually kind of pretty. Okay. But way back, I said, let our powers combine, right? We actually want to use this to make something that recognizes something useful, like NS. This is the long form way of actually recognizing those two characters in sequence, but you can see here I have char, n, and then bind, okay, bind the letter n, right, somewhere actually, I'm looking for the letter n, and then I return another parser that says, okay, well, bind again and look for the letter s, and then if we have made it into this actual layer in, 2 layers in, then we succeeded. Right, those first two binds must have succeeded if this closure inside, all the way inside, is being called. So I can just return result. And then I can apply and get the appropriate output when I want. What else? There are a lot of things to do, right? Like everything that I showed you is a very basic, just conceptual, like a proof of concept almost. But you're going to want error handling. You're going to want to actually accept a string as opposed to an array of characters. And you're going to want to be able to choose. Like maybe I want a lowercase n or an uppercase n. And that involves some other parser combinators and some other things, but we only had 25 minutes, and I had to teach you Swift. Right? All right. So my name is TJ. I'm starting at Iron Yard soon. If you want to catch me, you can catch me at GrioSpeak on Twitter and on various other social networks, app.net even, if you still use that thing. But that is about it. Just to prove that this actually works, all of this is what powers my app, which is on the store, called Chordal Text. And if you were to type in some of these things, right? I'm actually doing that. So if I said F, A, C sharp, if I typed it correctly, right? Like I'm using that to actually figure out what chord you're typing in. I'm constructing an object at the proper time, and giving that back to you, right? And one of the benefits of Parser Combinators is that, let's do this full screen, and let's parse it. Okay, parser, right? Is that in the best case, there's some oddities with Swift right now that keep this from being completely true, but in the best case, your code actually starts to look like the grammar that you're looking for. Right? So this is a little complicated because I'm doing a lot to actually transform that information since I'm looking for like chords, and musicians aren't great people like linguists. They weren't trying to create like a regular language or anything. They're jerks. So, but you can see here, right, at some point you get a pretty nice looking DSL to work with, where I'm looking for do and then associate that with C and all of that. And that all works. So, any questions? We have like 2 or 3 minutes left. I know that we went very quickly, but you know Swift now. Thank you. Yes.
I just came in for the next talk. I didn't know this was here. Is this on GitHub?
My code is not on, like the fully realized thing with like error handling is not on GitHub yet. At some point it will be, but I won't commit to a time frame.
Is there an official parser combinator library for Swift, or are you kind of pioneering that?
Yeah, this is me. So like there is not an official one. I should release this, but there is not an official one. Someone else has done it. I didn't like theirs as much as mine. But it exists in various forms. But I really do think that mine is closest to the paper, like and closest to sort of. It tries to sacrifice very little in terms of what happens.
Have you looked at other parser combinator algorithms like packrat combinators and such? Like
Yes, and I don't understand them well enough to try to steal from them yet. Yes, yeah. I mean, I very much want to, like, I want to figure out if there's a way to handle streams. And for that, I need to let go of backtracking a lot and stuff like that. So, yeah.
I have a solution for you. We should talk.
All right. All right, well, 1 minute left, so if there's one more question, I can answer that, but I don't want to push the next person back too much. All right, thank you very much.